By the end of this video, you will learn about the different types of AR hardware and hardware capabilities. AR hardware can come in many forms. The majority of AR is being consumed through a mobile device with a front and back camera. Other devices include VR headsets with pass-through and AR glasses. What can these different types of AR hardware do? Mobile devices have a large set of capabilities. One capability is that a mobile device with a back camera mimics the first-person view of the world that you get through AR glasses. Sometimes mobile devices aren't the best use case for augmenting the world around you, because creating new input patterns can be challenging. Mobile devices with front cameras work better when tracking someone's face. The camera can anchor to different facial features, such as the edges of one's lips, and can better understand facial movements. HoloLens is the hero AR device currently on the market because it augments the world around you. This AR hardware allows you to anchor content encompassing you and can even manipulate content that doesn't exist. The cameras on our mobile devices will continue to improve and have more power. The depth perceptions of cameras will improve to better support world understanding. And the newer artificial intelligence chips will improve and be more efficient at processing computer vision models. This will improve the ability of our devices to understand the world, amplify experiences for lower latency and higher resolution, and deliver more context and meaning to us. Since every camera needs light, low light can affect how well an AR experience is going to perform. AR experiences need to process in real time. It may not be able to achieve this if it doesn't have enough processing power. And once the experience is no longer responding in real time, it's useless. Additional hardware limitations are download times and connections. High-fidelity depth perception-based experiences might not be possible on devices that don't have a time-of-flight light detection and ranging sensor. Think about a game that fills your room with water. Without knowing where the walls and furniture are explicitly from the light detection and ranging sensor can make this difficult. For mobile AR specifically, old devices may be missing certain features, like the gyro chip. This chip is important because it calculates 3 degrees of freedom for rotation. An older or cheaper device might not have the processing power needed for your experience. When comparing Apple and Android products, this isn't as big of a concern for mobile AR, but the concern still exists. What you do need to take into consideration are the later and newer models of devices. If you're layering a number of different capabilities into your AR experience, those capabilities will directly influence demand on the processor. You need to remember that not everyone has the latest and greatest device to support the experience you created. If you're going for maximum reach to users, you won't be able to accomplish that if your experience only works on new devices. As such, make sure to also test your experience across a range of devices to ensure that older versions of a device can support your experience. What risks could you face for selecting certain hardware? The main risk for selecting hardware is compatibility. There may be incompatible APIs with mobile devices and even headsets, such as the way the device communicates its state back to the rendering engine. The rendering engine needs to make sense of it and send digital rendered content to the display system. What questions should you think about in terms of your hardware's capabilities and limitations? First, you need to know what you're trying to build. Do you know the software you're trying to use? Does the hardware you want to use support the experiences that you want your AR program to feature? Make sure you're aware of the compression settings for your images, as images are compressed in a slightly different way depending on the target platform.